I'm going to kick this off a little bit early today. Not a lot of time to be wasted. Gotta make sure that the audio comes in and then we can get started. Today is going to be a quick one. All right, excellent. Today is going to be a quick one, going over some of the questions that you submitted around enabling UART. I'm not going to go into the depths of UART implementation, but I'll give you some samples. All that stuff is in the description as well. So as we go through it, I'll point those things out. And also, what is the chosen keyword in a develop? What does it mean? How do you use it? So we'll cover both of those things today. Hopefully, let's see, my bandwidth just went down to red, but hopefully it won't be terrible like a couple weeks ago. If you haven't already, please subscribe, leave me a message, hit the like button, let me know what topics you like me to cover here on these weekly live streams. So, and let's go. First question. So, could you please make a video for NRF 9160 Feather to enable UART to an existing samples application? So, I'm not going to quite do that, but I will explain how to add or use a UART in maybe a non-driver context, because you can have devices that use UART as a driver interface, but then you can also use it directly. So I'll be talking about using it directly, and I'll show you actually in some of the drivers that I've written in the past actually use the UART driver, use the UART to actually communicate with the device. So, but it depends. Actually, before I keep going, probably not a bad idea to pull out the comments so I can see what you guys are writing. A non-driver context. Ooh, here we go. Don't forget to pop out the chat. And then people realize, hey, your microphone's not working. It really depends on, so first of all, it depends on your processor capabilities. Usually you're limited to 1, 2, or 3 UARTs. Bigger the chip, more UARTs you have. Make sure you use a unused or quote-unquote open DTS channel. So the way it works in the overlay or device tree is, if you notice, if you ever looked at it, it's UART 0, I2C 1, SPI 2, UART 3. So that it needs to be sequential. So you can't have UART 0 and also I2C 0. That's just the way device tree does. It kind of mushes everything together. So you got to make sure those are not conflicting. So that's all I'm saying there. It's just making sure that you don't have multiple devices that are conflicting with that same number. Goofy, yes. That could be improved for sure in Zephyr. But all it is some crazy macro stuff happening on the background, and if you use the same numbers, they'll collide with each other, and we don't want that. And then, so using UART by itself is kind of annoying. It's a little bit difficult. It's not like in Arduino where you're using like serial and you're writing and you're reading, where it's just like blocking. Unfortunately, it's really sad and difficult to use. And the more complicated features, like you can see these operating modes down here. There's 3 of them. You got async, polling, and also interrupt driven, and they all have different capabilities and functionalities. Async and interrupt driven are similar because they kind of operate on their own. If you've ever used or developed for Nordic processors before, you know that they have like the EasyDMA. Well, the async version, the async variety will use that functionality where it's happening and it's pushing stuff into a buffer in the background without you having to worry about it. Interrupt driven, it's more like you're getting an interrupt, you're processing that data all at once and then pushing it out, and then polling is like you're just pulling byte by byte. So in most cases, when I've ever done anything with UART, I've done using the async capabilities, but it really depends on your processor and also depends on if it's supported by the vendor that developed the hardware. So I've said this before. If you are using a different processor, you just got to make sure that they support those particular API calls. So just some important details. You can see here on the left here, I am using UART 2 because UART 0 is being used as a console/log output. And then interestingly here, I'm using the device within UART2, which allows it to be called out and them to be associated together. So this is the HPMA 115S0. That's the guy that I use connect to the air quality wing. Also put a link to this stuff in the description box below. And then in this case, I am using the async API, so that needs to be turned on. Also turning on serial, important. Both of them very important in this case. And then this should, for all of you, this should look pretty familiar. Again, I'm using the device get binding function instead of the device DT get. They're pretty much interchangeable, but I know that I've said this before. Device DT get is kind of like the preferred way to kind of get your drivers and devices from device tree and get it into your code. It also allows it to be done at compile time rather than at runtime. In some cases, even at runtime, you might still run into errors and things, so it doesn't solve all the problems. But in this case, we're just getting the device. And then importantly here at the bottom, you can see the UART callback set. So we're setting a callback, and this is what's actually handling all the events that are related to UART. So errors, receiving, transmitting completion, all that fun stuff is all being handled by this callback. And this is where all the work is being done, or especially in the async one where you provided a buffer. It's like, hey, here's a buffer, read bytes, and then let me know when it's done. So that's what's happening in this particular implementation. But it won't do anything unless you enable the receiver. So the receiver is the part of the UART driver that unfortunately uses a lot of power. Some of you who developed some kind of low power applications know that you need to kind of turn off that receiver because it will draw up to 1 milliamp of current, which will not work on many low power applications. But in this case, we're turning it on. We're pointing it to the buffer that we want to use. That second to last element there is, I think, the kind of the buffer size, or how many bytes you do expect to be written or read. And then the last one is actually a timeout parameter, I believe. So 10 in seconds or milliseconds, could be. So, and that allows you to kind of enable and receive bytes as they come in. So let's see. And then the callback, here's the callback. So this is what I was talking about. You have a ready event, aborted, done, buff request, buff released, disabled, and stopped. So you can get really crazy, and it can really go down a rabbit hole with this, where you can dynamically allocate memory into the buffer. It requests it. Once it's done, you can free it. You can go crazy here. So for this particular code and the HPMA stuff linked down below, I actually didn't allocate any memory. I think it was just using a static buffer. So that happened to work out well because it was only sending messages every second or so. So there was no need to get things lined up and get it so it was reading out to multiple buffers if it was high speed. This is running at like 9600 baud, pretty slow. Shannon, you had a question about the callback. This callback is most likely, I haven't looked into it, but it's most likely probably a system work queue, or a system work piece of work, or it could be some type of extra thread. I don't think it's another thread though. I think it's probably using the system work queue. So, and if I find out that I'm wrong, of course I'll share this to everyone to make sure I'm actually sharing the right information. Or if anybody knows, feel free to comment. But I'm pretty sure it's probably using the system work queue. And also there are some interrupt context stuff where the UART driver is creating an interrupt, but for this type of thing, it probably creates the interrupt and then triggers the system work queue, the work to actually start executing. So that's what usually happens. So the biggest thing is like in the TX done here. This is where the data is ready for you to read. So that's the point in time where you would take the data and send it off to some other piece of another thread, another work queue for work later on that you can use for processing, blah, blah, blah. So not ideal from a user experience development standpoint, but everything's there. You get all the knobs, you get all the buttons to know what the heck is going on with your UART. So pluses and minuses, of course. You can use this the UART _TX, and you can basically give it a buffer and a timeout time, and that's for writing multiple bytes at a single time. Or you can use it UART _pull out, and that will should have just made that a character, but that is just for writing one character at a time. So you have some options. Actually, the pull out stuff might not work when you're using the async. So that's something to bear in mind. Usually, the UARTX is actually will work in the async. If you're using the async capabilities. So to each your own. What I've found is that the polling API works, but it's not fast enough. So I've set it up with a thread that's high priority, where it's like, okay, I just want to listen to every single byte that comes in. It's just not fast enough. So it's a bummer, but in the past, that's why I've gone and used the async API, because it's just too slow. So your mileage may vary. It might be just a Nordic thing. So if you're using an STM32, ESP32, whatever, you might have better luck. But next question. So in device tree, what does the chosen keyword, I'll add that in there. What does chosen really do? And it allows you to, so Zephyr has lots of capabilities and lots of built-in features. And part of it is you have to tie maybe your hardware peripherals to those internal capabilities so that your application will know how to use them. So for example, Zephyr has the ability to log to console output. There's also Bluetooth HCI, which is like basically you can attach a Bluetooth device to any other Zephyr-based device, and your device will basically become a Bluetooth device, which is, I've used this several times. I'm using it on a project right now. It's awesome. And then MCU Manager for OTA, or over-the-air, not over-the-air updates, but sending things or data, uploading I can't talk today. Updating your firmware over UART or USB kind of tells you what interface you want to use there. So that is, for example. And then I've actually put a bunch of examples together so you can actually see, like, here's the default. Here's some other ones that use different features in different parts of Zephyr. So this one is the default from the NF9160 160 Feather, and I'm just calling out everything, and it's going to UART 0. That includes MCU Manager, the shell, and console. Now, this is the default, but what if you want to add on? Or what other features? Or do I really have to use the console on UART 0, or can I move the console to something else? And that's the point of this here, is you can see. So for instance, like, here's a completely disparate feature that we're using chosen for. So instance, Nordic, because of the partition manager and the features of the Cortex M33s, they had to add this extra kind of device tree binding that will tie the particular flash device to the functionality in the code so you can get the external flash working. This is Nordic specific, but it just gives you an example of one way of using the chosen keyword in a device tree binding or DTS file or overlay. Here's a more crazy one where there's a lot of other things going on. Like, for instance, I've reassigned the console shell UART MCU Manager to UART 2. I've again used that external flash, and I'm defining that external flash That's not really shown here, but another thing here is the HCI UART. So it's for that one, it's called Zephyr, BT-UART. And it's using the low power UART interface that's provided by Nordic. They have a binding specifically called Nordic's, NRF SW-LP UART. And remember when I was saying about turning off the receiver for power savings? Well, this particular driver functionality disables the receiver when it's not being used, and that's how it's like called low power UART. It's just some more software to interface with the normal UART and make sure it has some type of flow control, but also to keep it as low power as possible when it's not being used. But you can see another chosen item only if you're using it in the firmware. So just because this is maybe one misconception is that once you connect something in the overlay or your device tree, it's not enabled in your code. Like if you just add it to your overlay and then recompile, it's not going to do anything. You have to make sure on the configuration side, those configurations are enabled. And then in the code, you're actually calling that code to, in some cases, when you enable it and it gets initialized, it's on startup. But if you want to further use it in your code, then you have to call any type of initialization functions and also functions to enable or disable them. So it's a kind of a three-pronged approach. You have to have it in your overlay, you got to have it in your configuration, and then you got to use it in your code. And if any of those three things are missing, then whatever you want to do is probably not going to work. So important concepts in Zephyr. And that's why I always, every time I give an example, I'm like, here's the overlay, here's the config, here's the code. Without any of those three, if we don't have any of those three things, it's not going to work. So chosen here, this should give you an idea of how to use it and what's there. And what I would say is, and I say this on the next slide. I'll just skip to the next slide and go back. The important thing is it ties everything in Zephyr, the functionality, console, MCU manager, anything like that, to the specific hardware device you want to use for it. So if you have a UART and you want to tie it to the console and maybe tie another one to MCU manager or whatever, you can do it. If you want to see what other projects or other devices and how they handle it, literally search for chosen with the bracket or a space and a bracket or curly Q and search for it and see what other functionality in Zephyr is there that you can use. Typically, if you know there's a feature for your device, I would look and see if there's a specific chosen item for that. You're not always going to have one. This is more like Zephyr, like the core of Zephyr, rather than like extra features and functionality. You might have something where you have to use compatible, like define it elsewhere and use the compatible keyword instead of using the chosen. Chosen is more like core Zephyr functionality. So hopefully that made sense. But please let me know if you have any questions around it. Leave a message and maybe we can talk about it next episode. But back to UART. Adding UART is just like adding other peripheral or device. Not too different, not too, not surprising. The hard part is, picking the right API and making sure that it's supported by your device. Remember, we have the async, the interrupt driven, and also the polling. So in this case, I've shown mostly async usage, but it's just, you got to use whatever your application supports the best. So, and especially if you have something that's sending a lot of data back and forth, you're going to be wanting to use the interrupt driven or the async APIs for that. And it's a matter of trial and error and making sure that you get it right. Originally, I had implemented using an async, talking between two processors, kind of my own protocol, and it was just a nasty mess. Would not recommend it. So if there's a way for you to keep it simple, always keep it simple, because this stuff can get hairy pretty fast, especially if you're going at higher speeds, because then you're throwing in the potential for errors. Like anything at like 1 meg baud, I mean, you're going to have problems. You're going to have data issues, especially if you're not using flow control. So So that is it for today, I think. This will be, as I said, that was a quick one. If you have any questions, suggestions, or things that you want to see covered in the next live stream, please let me know. Send me a message, leave a message below, send a carrier pigeon, let me know. And I'd love to hear from you, and hopefully I'll be able to help answer your questions related to Zephyr, because it can be a beast sometimes. That is it for today. Thank you for being here, and we'll see you on the next one.